Okay, so here's another situation you could use permutations for. Let's say we were running a math competition and we needed a committee to organize it. This is something actually that we do. We have at Delta, we have a middle school math competition that we run every year. We bring middle school students in and have them compete, do a math test, and have a bunch of activities, and it's kind of like this big fun carnival day. But anyway, we have different positions, different coordinators. We have an organizing committee that has a chair and a vice chair, and then we have a volunteer coordinator and a test writer. Those are the main four positions that we have. There's also a committee with a planning committee that has a few extra people on it, but just these are the four kind of lead positions to develop that competition day. And so this would be a good example where you could use permutations. Let's say you had 15 faculty in your division and you needed to choose these four people. And so the question is, how many different ways can you do that? 4 people out of 15. So, and the order is important because the order in which you pick them puts them in a specific position. Okay, and so you wouldn't want to just scramble the order arbitrarily. So every time you put a new order up here, even if it was the same 4 faculty, it would count as a different permutation. So how many different ways could you arrange these? That's the question. Well, rather than sit there and try to work through 15 different faculty members and putting 4 in at a time and trying to figure it and just count them up, that's ridiculous. What we're going to do is use this factorial idea. So we're choosing, in this case, we're looking at 15 permute 4. So 15 is the size of the overall set, 4 is the number that you're permuting, so it's 15 permute 4, and that gives you an n value of 15 and an r value of 4. And so the way that you calculate this then is you do the n factorial on top, so that's 15 factorial over, and remember you're dividing out all the ones that aren't being used. So if you're using 4, you're dividing out the 11 factorial. And so that's where the n minus r is. N minus r would be the 15 minus 4 factorial. That gives you the 11 factorial, which are the number of faculty that do not fill those positions. Okay, and so we have 15 factorial over 11 factorial, right, 15 minus 4. And if we just write those out, you could write out all the 15 factorial, but that kind of gets tedious. 15 times 14 times 13 times 12 times 11 times 10, da da da. But notice, once you hit the 11, you're going to start repeating ones that are on the bottom. 11, 10, da da da, all the way down to 1, right? 2, 1, 2, 1. So another shorthand way of writing this is to just separate off these first 4 factors. Call this 15 times 14 times 13 times 12 times 11 factorial, right? The rest of this is 11 factorial, and on the bottom you have 11 factorial. Okay, and so if you have 11 factorial on top and 11 factorial on the bottom, they cancel. Everything from that point on cancels, and all you're left with is 15 times 14 times 13 times 12. Okay, and of course, I am not doing that in my head right now. So we've got 15 times 14 times 13 times 12 is 32,760. 32,760 permutations. All right, well that is a lot of permutations. And you can see that that's a lot just for 4 different faculty out of a 15-person division. That's quite a few different permutations. And so you can see how you wouldn't want to just do it by trial and error, just by testing it out, saying, pick faculty number 1, faculty number 2, put them all in, and just count up the number of ways, because you'll be counting for a long time. lot of different ways to permute 4 faculty out of 15. So, but again, basically what you're doing is you're taking n factorial and dividing out the ones that aren't being used. And so another way, rather than actually writing all this stuff out, which is helpful, I think that's good. If these numbers are bigger, you're still not going to want to write out all this list. So it might be easier to just write out, 15 times 14 times 13 times 12. And then once you hit the number on the bottom, you just ignore the rest. Okay, so you don't even have to really write out all that other stuff. You can, they cancel, but another cool thing is that your calculators, your graphing calculators, have a factorial button on them. Where'd it go? Actually, it's not a button. Most of them have them in the catalog or under math somewhere. Where are they? Oh, I thought so. Oh, there they are, under probability. Ha! Okay. I should know that real quick, but I didn't. Anyway, if you take your calculator and go to the math menu, you can go over to probability, and you can see the exclamation point, which is the factorial notation right there at the 4. So actually what I would do if I was calculating this, I would actually type in the number 15, then I go to math, over probability, and down to 4, hit enter. So that's 15 factorial, and then I would divide. Where's my divide? There's divide. And then I would divide by 11, and then again go to math, over to probability, down to factorial, hit enter, and you get your 32,760. Okay, so you can do that quickly on the calculator. If these numbers get to be kind of big, if I was doing 32 factorial over 26 factorial or something like that, I don't want to write it all out. So just for instance. But anyway, that's how you use this formula. So you have a set of n, which in this case is 15, and a number that you're pulling out of that to permute, and that's in this case 4. Now, why did it work so well without this formula when we worked with the 2 other examples, the 5 movies, where we just watched all 5 of them, or the letters T, A, E, and T? Well, it's because we were permuting the whole list. So this formula kind of reduces down. If I'm taking, if I'm permute 5 movies out of 5, right? Then you're doing the 5 factorial on top. So you get 5 permute 5, which is 5 factorial on top, over, well, n minus r, which is 5 minus 5 factorial. Right, and what did we say? Well, 5 minus 5 is obviously 0. What did we say 0 factorial is? 1, which is helpful. So it's really 5 factorial over 0 factorial, 5 factorial over 1, which is just 5 factorial. Okay, so the formula essentially reduces down if you're using all of the elements of the set. For instance, if I wanted to take this set of faculty and I had a specific job for all 15 of them, and I wanted to permute all 15, that would be just 15 factorial, which is a way bigger number than this, okay? It'd be 15 factorial over 0 factorial because I'd be leaving 0 of them out, all right? Here I'm leaving 11 of them out, and so 11 get divided out on the bottom.